4-team high wire, and it's made up of me, David, Taylor, Greg, and Samia. Our client is Michelle Grayson. She's a special needs student teacher and she works at the Broomfield High Intensive Learning Center. And she wants an easy to use game for her students in class. So, in our first client interview with her, we learned a lot about this project. We learned that she wants the game to be uh, a familiar game for the students so that it's easy for them to pick up. She wants a game that is not very complex so that way they can understand it and it doesn't take too much cognitive abilities. And she wants the game to be accessible to all of them. So it takes into account all their disabilities.
So in that initial client interview, we did find out that some of the games the students are familiar with are Beat the Count, Uno, and Sorry. So we began our design process just by using those 3 games to brainstorm how we could make it easier for students to play games in class, even with the cognitive and physical disabilities that they may have. And while we were trying to evaluate the different options we had, we decided our most important criteria was that the game had to be simple to use, durable, easy for us to produce, engaging and appropriate for the audience. We said the last one, appropriate for the audience, was really important because we want to keep in mind that even though these students have some physical and cognitive disabilities, they are still high school students and we should treat them as such rather than just trying to make a kids game. So the design we finally decided on was a random display of the Sorry game. And if you go to the next slide, you can see that initially we wanted our display to be button activated. So each time you press the button, a new card appears on the screen. And we were going to build a 3D printed casing for the device along with the Arduino that we were going to use to program it so that our project itself would be one device. And we wanted that device to be battery powered so that it could move around and be easily used in the intensive learning center and it didn't need to be plugged into a computer or anything. However, because of the strange situation that we're in right now, we had to modify our design when we switched to remote work. And this presented some interesting challenges for our team because we're not all in the same room manufacturing a project together. We're all spread out and we're even in different states. So we needed to figure out how to kind of get that to work. So we were able to break our design down into different components. We had one person who took the display in the Arduino and did the programming for that. We had someone else doing the CAD model, and we were able to kind of work together to produce each component of our design individually. So the modified design that we settled on for our final project was a touch screen rather than a button activated display, just because we were all remote and we didn't have the electronics capabilities of hooking up a button. And we built a CAD model rather than actually printing that casing. And we decided to eliminate the battery component from our design just because in this remote setting where we're all separated, it's easier to just have the Arduino plugged into a computer. However, if we were going to build this in person, we would likely bring back that battery component.
This is a block flow diagram that we created in order to visualize and plan how we would assemble our device. Red lines on the diagram represent the flow of power, while blue lines represent the movement of data through the system. Our plan is to have a battery connected to an Arduino, or it was rather, and we would have a power switch and a power converter in between. The Arduino would then connect to our LED display, and tapping on the screen would flip to the next card. Our prototype consisted of 2 components, of which Samiha and Taylor worked together on the first, while myself and David completed the second. The first component of the prototype was a small box made out of cardboard. We wanted to show how large the device would be, as well as how we imagined it would be held by the user. We dimensioned this box to be the exact same size as our final product, and we even included a small hatch in the box to demonstrate how and where the batteries would be stored. To demonstrate the functionality of our product, we created a simple circuit with an Arduino on the right. It simulates a deck with 5 different cards that one could see in the game Sorry. When one presses the small button on the circuit, a random card is displayed to the console. Once all 5 cards have been displayed, the code automatically reshuffles the deck. When the time eventually came to scale up our prototype to our final product, we used nearly identical algorithms to simulate the full deck of cards.
Since we did not get a chance to test our product in person with the students and receive their direct feedback, we tested our display under different circumstances to find where there could be issues. We tapped different parts of the screen to make sure all of the different parts worked. And we also tested the time it took for the display to load, which was approximately 6 seconds. When testing, we ended up finding an error. If the display was pressed down for a few seconds rather than tapped, the card would change multiple times. After finding this error, we adjusted our code to lengthen the number of seconds between each card display. This did not fix the problem completely, so we still need to instruct the students to tap the screen rather than holding it. Some things that we would do differently in the future would be to add a button if the client preferred. If our students would use the game better if there was a button rather than if the screen was tapped, then we could easily add a button. Also, we would have tested the display in person with the students to receive their direct feedback. Additionally, we could add an SD card to display more complex images. And also we could program the game to display multiple card games to make it more versatile and fun to play. For example, we could include a deck of cards or the game Beat the Count, which they play commonly in their classroom. Despite the fact that we need to cut this product short, our product is fully usable and with a few additions can be given to our client to be played in a class full of students.